okay, today. Now, students are joining. So, recap of last lecture we'll take. So, revise the content you have learned in last lecture. Okay. So, student, in last lecture, you have studied the advantages of frequency response, right? Advantages of frequency response design that you have studied. You have to remember all these points. Then I have taken this frequency response. So this is the block diagram of control system, closed loop control system we have taken for LTI system, when input is sinusoidal in nature. Output is also sinusoidal in nature, but only change in, yes, only change in amplitude and phase at the output. Okay, this is nothing but frequency response. So you know very well the definition of frequency response, okay, that we have defined. Now, for closed loop transfer function of LTI system, so you know how to write transfer function in time domain. So in time domain, the transfer function you have written in terms of GS, okay, that is a ratio of Laplace of output to the Laplace of input. The same thing I have written over here, G of S divided by 1 plus G of S into H of S. Now this is the transfer function for closed loop of the LTI system. But in frequency domain analysis, what you have to do? You have to replace this S by J omega and write the transfer function. Now, in frequency domain analysis, transfer function is denoted by this letter mj omega is equal to yj omega divided by rj omega is equal to, just put S is equal to J omega, you will get transfer function in frequency domain analysis. Mj omega is equal to gj omega divided by 1 plus g j omega h j omega. Now you have to remember this term, okay, that you have studied already. Now frequency domain transfer function mj omega, that can be expressed in terms of two parameters. First one is amplitude, magnitude, and second one is phase. So if you take mod of this mj omega, you will get magnitude, first term, okay. So mj omega mod of this is nothing but magnitude. How to find out magnitude? You have to take modulus of this. Then how to take phase? Angle of mj omega is nothing but phase of this mj omega, frequency domain transfer function. Okay, so you have to remember these two things. You are going to find out mod of transfer function in frequency domain. You are going to find angle of mj omega, that is nothing but phase in frequency domain analysis. So student, please write all these equations. Okay, you should know all these things. I'm not going to revise again. Now, magnitude is equal to mod of mj omega is equal to this term, or you can write this term. This is nothing but your gain characteristics. And phase of mj omega, that is phase of closed loop transfer function in frequency domain analysis, mj omega, you can write angle of mj omega or is equal to phi mj omega. So take angle of numerator minus angle of denominator. Okay, and this is nothing but phase characteristics. So this is, I have taken one of the simple example, that is phase and gain characteristics of an ideal low pass filter. For example, I have explained. Then you have solved one example, that is frequency response of capacitor. Single capacitor we have taken and we have plotted the frequency response of this capacitor. Now when taking only single capacitor, consider only one capacitor, okay, and input to this capacitor is voltage. Which type of voltage? Sinusoidal voltage. And output of this capacitor is nothing but current. So the equation for current flowing through your capacitor, I is equal to C into dV by dt, where V is input voltage and I is output current. I is output, V is input. Now determine the sinusoidal steady state response of this capacitor. So we have taken transfer function in time domain, okay, is equal to Cs. In frequency domain, you have to put replace this S by J omega. So frequency domain transfer function in frequency domain analysis is denoted by letter mj omega is equal to C into S. So C into J omega. Replace scalarly, S is equal to J omega. So C J omega. Now find out magnitude and phase. This is the equation for transfer function in frequency domain. Okay, take magnitude mod of this you will get magnitude. Take angle of this, you will get phase angle, phase between input and output. So taking mod of this, mj omega is nothing but mod of cj omega is equal to c omega only. So this is magnitude of the response, okay? And this is nothing but angle of transfer function in frequency domain analysis is equal to phi m is equal to 90 degree. Why 90 degree? Because input is sinusoidal. Derivative of sinusoidal signal is nothing but cosine signal, and there is phase shift between sinusoidal signal and cosine signal, that is input and output. Between input and output, there is a phase shift of 90 degree. So angle is equal to 90 degree for capacitor. So this much you have studied already, right? So gain equation is nothing but mod of transfer function in frequency domain analysis, that is mj omega is equal to mod of cj omega is equal to c omega, and phase characteristics is equal to this equation, that is phase is equal to 90 degree. Now what is output? Output is nothing but I of j omega is equal to, this is transfer function into, this is nothing but input. So ij omega is equal to transfer function in frequency domain analysis, that is denoted by letter mj omega into input. Input is vj omega. So this is the equation for output. Okay. Now student, you have to remember these two statements. Okay. For a unit amplitude sinusoidal input voltage, the output I will be sinusoidal with magnitude c omega that you have studied, and the phase of output will lead to that of input by 90 degree. Okay. Because it is capacitor. And the equation for capacitor current is equal to dv by dt. So you have to note that for this example, the magnitude is proportional to the input frequency, while the phase is independent of frequency, right? This much part you have studied already, right? In last lecture. Now, let us start with frequency domain specification. Now, today you are going to study the frequency domain analysis of second order system. Okay. So before starting that, you should know the frequency domain specifications. So what are the frequency domain specifications? Now, today you are going to study frequency domain specifications of second order control system. Okay. So this is nothing but magnitude of your system, magnitude of your transfer function, and this is nothing but phase of your transfer function, right? So transfer function equation is having magnitude and phase. So this is nothing but magnitude. Okay. On this axis, y axis, I have taken magnitude of transfer function mj omega. I have taken omega on x axis, right? So this is the plot for frequency domain analysis. So according to equation, when omega is equal to 0, the magnitude is this much. Okay. At omega is equal to omega r. Omega r is nothing but resonant frequency. The amplitude is maximum, and this is nothing but maximum resonant amplitude, or you can say resonant peak, denoted by letter mr. That is having maximum value at omega is equal to resonant frequency omega r. Okay. What is resonant frequency? That is equal to omega r. Now, bandwidth. Coming to next specification in frequency domain analysis, bandwidth. Now, this much is nothing but your bandwidth, and you are going to find out bandwidth at omega is equal to resonant frequency. Okay. So we'll see one by one all derivation in next slide. Now, second one is nothing but your phase plot. So phase is nothing but phi m, phase of transfer function, phase angle of m of j omega is nothing but phase. So phase is equal to 90 degree. So you can plot this phase. So you have to remember frequency domain specifications. That is nothing but resonant peak denoted by letter mr, resonant frequency denoted by letter omega r, and bandwidth denoted by letter bw. Now how to find out this omega r? In order to get the equation for omega r, what you have to do? You have to differentiate your magnitude, that is magnitude of mj omega r. You have to differentiate with the respective omega and equate is equal to 0. If you simplify, you will get equation for resonant frequency, right? So you are going to do all this simplification. So student, please be ready with notebook and pen. Now, frequency response of a prototype second order system. Now students, you are going to study today frequency response of prototype second order system. So give the heading. Students, please give the heading. You are supposed to write all these things. Without writing, you will not get anything. You have to write all these equations. Okay, and you have to revise it today itself. So give the heading. Requesting all students, please give the heading. Write in your notebook. Frequency response of a prototype second order system. So for this second order system, the closed loop transfer function you can write in this form. So m of s is nothing but transfer function for closed loop control system. So what is transfer function in closed loop control system? That is nothing but Laplace of output to the Laplace of input. Y of s divided by R of s is equal to. So you can represent the closed loop transfer function for second order system by this equation. So you have to remember this equation. There is no any other way. So the closed loop transfer function is given by this equation for second order system. Omega n square divided by s square plus 2 zeta into omega n s plus omega n square. Now, what is this omega n? Omega n is nothing but natural frequency, and this zeta is nothing but damping factor, damping ratio or damping factor. So depending on this omega n and zeta, there are 3-4 types of your second order system. Okay, depending on this zeta factor. Okay, damping factor you cancel. So you have to remember this equation for second order system. Again, you are supposed to write and remember this equation. So write closed loop transfer function for second order system is equal to omega n square, that is natural frequency, divided by s square plus 2 zeta omega into s plus omega n square. Always you have to represent your second order system closed loop transfer function by this equation. So this is the equation, closed loop transfer function for second order system. Okay, so remember this equation. Now its frequency domain transfer function. Its frequency domain transfer function. So in frequency domain analysis, what you have to do? You have to just replace this s by j omega. So your equation for transfer function in frequency domain analysis will be like this. That is denoted by letter m j omega is nothing but frequency domain transfer function denoted by letter m j omega, right? Is nothing but ratio of output to the input, Laplace of output to the input. So y of j omega to r of j omega is equal to. So frequency domain transfer function is equal to omega n square as it is. Just put instead of this s j omega. So omega n square divided by j omega square plus 2 zeta omega n as it is. Replace s by j omega, bracket में j omega plus omega n square. Now this is nothing but this is nothing but frequency domain transfer function. Okay, first one is transfer function of second order in time domain. Okay, and second one is nothing but frequency domain transfer function denoted by letter mj omega. So student, henceforth you are going to write this equation. for frequency domain transfer function. Okay, so remember second equation. This is equation for transfer function in time domain. This is equation for transfer function in frequency domain. Okay, now define u is equal to omega divided by omega n. So I want my transfer function equation in this form, that is 1 divided by all these things. So what I am going to do, I am going to divide numerator and denominator by omega n square. So divide your numerator and denominator by this term omega n square. So काय होईल आपण ओमेगा n square ने जर डिवाइड केलं न्यूमरेटरला आणि डिनॉमिनेटरला, so you will come to know that after derivation you will get one term, u is equal to omega divided by omega n. This omega n is natural frequency, whereas this u is nothing but normalized frequency. So please note this u is nothing but normalized frequency. So you can write for u is equal to omega divided by omega n. Okay. Now put in transfer function also mj omega. So you will get equation for transfer function, that is frequency domain transfer function. Mj omega is equal to mj u. Now we are going to write equation with normalized frequency. This u is normalized frequency. So you are supposed to simplify this equation. Okay, divide and multiply, divide this term numerator and denominator by omega n square. So you will get mj u is equal to 1 divided by. So here you will get omega divided by omega n, right? Plus 2 zeta omega n divided by omega n square गेला, बरोबर? So omega n cancel झालं, omega divided by omega n into j. Okay, here you will get plus 1, right? So I have written this equation 1 divided by, here omega n square divided by omega n 1. Okay, divided by, I have written in this way, this is 1 plus j as it is, j into 2 zeta u, because why u is equal to this omega divided by omega n. So this u is nothing but normalized frequency, I have taken as it is, minus का j square is equal to minus 1 and omega divided by omega n. So that is nothing but u and square of that. So my equation for frequency domain transfer function is equal to, in terms of u, in terms of normalized frequency, is denoted by letter mju is equal to 1 divided by 1 plus j 2 zeta u minus u square. Okay, just I have put up omega divided by omega n is equal to u, and what is u? U is nothing but normalized frequency. You are supposed to write all these things. Okay, now coming to magnitude and phase of second order system as usual. Okay, so magnitude, we are going to write equation for magnitude and phase. So the magnitude of mju is given by, with normalized frequency, frequency domain transfer function with normalized frequency is denoted by letter mju. So magnitude of mju is nothing but mod of mju. So take mod of mju, you are having this equation. Okay, take mod of this. So how to take mod of this? By taking mod of this means you will get this equation 1 divided by under root of square of this two term and addition. Okay, so 1 divided by under root into bracket 1 minus u square whole square plus 2 zeta u square. Okay, bracket complete, under root में. This is nothing but magnitude of mju. So remember this equation, this is very important. You are going to enter this equation in Scilab code. Okay, while finding the response of second order system. Okay, so remember this equation in terms of normalized frequency. Okay, now coming to phase, next part of transfer function in frequency domain, that is nothing but phase of mju with normalized frequency. So mju is nothing but angle of mj omega, that is equal to phi m j omega. So phi m j omega is nothing but angle is given by this equation minus tan inverse of, yes, 2 zeta u, this term, divided by 1 minus u square. This term divided by this term is nothing but angle b by a or y by x. Okay, so tan inverse of 2 zeta u, this term, divided by this term, 1 minus u square. Now this is nothing but phase of mju. Okay, so we are having now magnitude, equation for magnitude of mju. We are having equation for phase of mju. Now this equation is nothing but your gain characteristics. This equation is nothing but your, yes, phase characteristics. So from this equations, we are going to find the equation for maximum peak or resonant peak. That is nothing but mr. Resonant peak is denoted by letter mr, and you will get equation for mr is equal to 1 divided by 2 zeta under root 1 minus zeta square. Okay, so let us see how this equation is coming. Okay, rather you have to derive it. Okay, now the resonant frequency of mju is given by this equation. Now you are going to find out resonant frequency of mju. How to find out that resonant frequency? For finding the resonant frequency of mju, normalized frequency, for that you have to take derivative with respect to u. Okay, and equate that derivative with respect to u is equal to 0. काय करायचं आहे तुम्हाला? In order to find out resonant frequency of mju, what you have to do? You have to take derivative of this mju and equate that derivative is equal to 0 and solve. You will get equation for resonant frequency ur. Normalized resonant frequency ur is equal to this equation. Ur is equal to under root of 1 minus 2 zeta square. So what is phase equation? This is the equation for magnitude. Students, you are supposed to write this thing. So this is the equation for magnitude, right? Magnitude of mju is equal to mod of this 1 divided by under root this term square plus second term square. So 1 minus u square bracket square plus 2 zeta u square, whole thing bracket complete, whole thing is under root. That's why I have taken 1/2. Now this is the equation for magnitude of mju. Now this is the equation for phase of mju. That is given by this standard equation minus tan inverse of this term divided by this term. Okay, so 2 zeta u divided by 1 minus u square. This is nothing but magnitude. Now and resonant frequency of mju you will get by just taking derivative of this mju. Okay, and equating is equal to 0, simplifying for natural normalized resonant frequency ur is equal to, you will get under root of 1 minus 2 zeta square. So in between जितना भी लिखना है आपको करना है. In order to get that equation, ur is equal to under root of 1 minus 2 zeta square. So student, please do it. ये हो गया ur, normalized resonant frequency. So now you know very well ur is equal to, u is equal to omega divided by omega n. Omega n is nothing but natural frequency, right? So you can write ur is equal to omega r divided by omega n. So you will get equation for omega r. Omega r is equal to omega n, yes, into ur. What is ur? Ur is equal to under root of 1 minus 2 zeta square, and hence we are having the equation for resonant frequency omega r is equal to omega n into ur. So omega n into ur is nothing but this equation. So put into this equation, ur is equal to under root of 1 minus 2 zeta square, right? So we are having now equation for resonant frequency of mju. So this equation is also important. So student, please write this equation for resonant frequency in square bracket. So this is the equation for resonant frequency, okay, of MJU. This is very important. You are supposed to write all these equations in summary. Give the heading second order second order system, control system, and you have to write all these equations one by one. Now, since here frequency is a real quantity, okay, frequency is a real quantity. It requires 1 minus 2 zeta square that should be greater than or equal to 0, okay, and hence the zeta should be less than or equal to 0.707. Just wait. Is it visible now clearly? Are you with me, students? So since frequency is a real quantity, it requires 1 minus 2 zeta square should be greater than or equal to 0. Now, if you equate this is equal to 0, what you'll get? You'll get zeta is equal to. So what is that zeta is equal to? Zeta is equal to less than or equal to 0.707. Now, with this, you are going to draw the bandwidth. Okay. Now, let us see how you have derived that equation. Okay. Are you with me, students? Now, starting with resonant frequency, resonant peak, and these are the derivations related to resonant frequency, resonant peak, and bandwidth of second order control system. So starting with this diagram, again, I have drawn this diagram, that is RS is input. Okay, this is summing point. Okay, and this is nothing but unity negative feedback system, because negative sign is written over here. Okay, so consider second order control system. Now this is the block diagram for second order control system with unity feedback, and feedback is negative with negative unity feedback. Second order control system. This is the block diagram. This is the transfer function for process. This is the transfer function for feedback element. H of S is equal to 1. Hence we are calling this as unity feedback system. And negative sign आहे feedback signal, hence negative feedback. Okay, so consider this second order control system. Okay, that is unity control system, unity feedback and negative feedback. So you can write closed loop transfer function for this block diagram for second order control system. You can write closed loop transfer function is equal to, in time domain, C of S is equal to R of C of S divided by R of S is equal to G of S डिवाइडेड बाय 1 प्लस, यहाँ माइनस है, हम क्या लिखेंगे? प्लस लिखेंगे. यहाँ प्लस होता है तो हम क्या लिखेंगे? यहाँ माइनस लिखेंगे. सो नेगेटिव फीडबैक है, सो आई हैव टेकन 1 प्लस G of S into H of S. Okay, multiplication of G of S into H of S. Okay, this is output. Now you can write this G of S. So in second order system, this G of S is having this equation. Okay, so you can write G of S is equal to omega n square divided by S into bracket S plus 2 zeta into omega n. Omega n is natural frequency, zeta is damping factor again. Okay, so this is nothing but transfer function. So put this equation over here. G of S is equal to omega n square divided by S into bracket S plus 2 zeta into omega n bracket complete divided by 1 plus GS HS. HS is 1. So 1 plus again G of S, same term, omega n square divided by S into bracket S plus 2S 2 zeta into omega n bracket complete. Right? Now simplify after this. So C of S divided by R of S is equal to omega n square cancel करायचं आपल्याला. So this is nothing but M of S. Okay, is equal to omega n square divided by S square. Now S square plus 2 zeta omega n into S plus omega n square. So what I have done? Yes, taken LCM. Okay, multiply this 1. This term get cancelled. So you will get omega n square divided by S square plus 2 zeta into omega n into s plus omega n square. Now this is the equation for transfer function, closed loop transfer function for second order control system with unity feedback and negative feedback. Okay. Now in frequency domain analysis, now this is the equation in time domain analysis, right? In terms of S, hai na? C of S divided by R of S is nothing but transfer function in time domain analysis. So we are going to replace S, this S by J omega in frequency domain analysis. Now coming to frequency domain analysis, just replace this S by J omega. So you will get equation M of omega is equal to omega n square divided by S square is nothing but J omega, J square is nothing but minus, so minus omega square plus 2 zeta omega n, S is replaced by J omega plus omega n square. So this omega n square and this omega n square get cancelled if you take common. Okay. So while taking common, what you have to do? You have to divide this term omega n square divided by this. So you'll get minus omega square divided by omega n square. Okay. Plus 2 zeta into, yes, 2 zeta into omega n cancel with, right? Into omega divided by omega n. How omega hai na? Into j plus omega n square divided by omega n is equal to 1. So plus 1. So you'll get this equation. Now just cancel out this term, omega n square numerator and omega n square numerator cancelled. So what you will get? 1 divided by this term. So you will get this term. Just put now omega divided by omega n is equal to u. So put this u is equal to omega divided by omega n. This u is nothing but normalized frequency. Okay. Now you are going to write equation for magnitude and phase. So mu is equal to 1 divided by this term. I am writing in reverse way, 1 minus u square. I am putting omega divided by omega n is equal to u. Me ithe u put kela, ithe pan u put kela. So my equation become like this. You can write the equation for mu. U is normalized frequency is equal to 1 divided by 1 minus u square plus j into 2 zeta into u. J into 2 zeta omega by omega n is nothing but u. So you'll get this equation. Now this is nothing but, just wait, I'm just okay. Is it clear now, students? Are you with me? Okay. So just by putting omega divided by omega n is equal to u. What is u? U is normalized frequency. Okay. And you will get this equation for mu. This is the equation for m omega in terms of omega and omega n. By putting omega divided by omega n, you will get mu. That is transfer function in terms of normalized frequency is equal to 1 divided by 1 minus u square plus j2 zeta into u. Okay. Now take magnitude of this and phase of this. You are going, this is transfer function. Okay. In frequency domain analysis. So the transfer function of frequency domain analysis, in that case, you will get that transfer function you can represent in terms of magnitude and phase. Now find out magnitude first. So in order to find magnitude, take mod of this mu. So mod of this mu is nothing but 1 divided by under root. Okay. This term square, a square plus b square. Okay. So take 1 divided by under root of 1 minus u square bracket square plus second term square of this second term into plus 2 zeta u square. So 2 square 4 zeta square u square. So this is nothing but magnitude of your transfer function in frequency domain analysis. Now find out phase. Find out phase. Okay. Magnitude आपने देखा. चलो अब आगे चलते हैं. Any doubt up to this? Students, are you with me? Any doubt up to this? Got all the equations,
Yes,
all the steps?
no, ma'am.
You are supposed to write all these things in your notebook. Okay? Now, चलो आगे चलते हैं. अब हमको क्या करना है? Yes. Take derivative of this. How to take derivative of this? In order to find out the resonant frequency omega r, इथे काय मिळाले आपल्याला? You are having this. हे बघा, इथे काय मिळाले आपल्याला? Magnitude of u, magnitude of m of u. Okay, 1 divided by under root of 1 minus u square bracket square plus 4 zeta square u square. So this is the magnitude. Okay, so let us find out resonant frequency, because we are interested in resonant frequency, that is omega r. So for that, what you have to do, you are having this equation mod of mu. Okay, this is equation you are having mod of mu. You have to take derivative of this and equate that derivative is equal to 0. Then you will get resonant frequency. Okay, so derivative with respect to u of magnitude of mu is equal to this. So how to write? Take derivative d by du with respect to u. You are going to take derivative of this term. So derivative of this term. Okay, that is nothing but you have to use u by v rule. U divided by v rule while taking derivative, and by using that rule I have written this equation. Are you with me, students? Take derivative of mod of mu, equate that the derivative is equal to 0. Simplify further, you will get equation for resonant frequency. Okay, these are the steps. Now take derivative by using u by v rule. Okay, so first of all, you have to write in that rule divided by v square as it is. So this is my v term, square of this. Okay, then v into derivative of u minus u into derivative of v. So you can write by using this equation. Okay, first term, or v into derivative of u. So v term is nothing but 1 minus u square चा square plus 4 zeta square into u square raised to half. Okay, इथे square घेतला म्हणजे half आणि square get cancel. So that's why I have written this term v square. Now v as it is into derivative of 1 is equal to 0. So this term becomes 0 minus u1 into derivative of v. So I have taken derivative of v, that is 1/2 into bracket 1 minus u square का square plus 4 zeta square u square raised to काय आहे? हाफ आहे. हे रेस्ट मायनस हाफ झालं ते परती आल्यानंतर, राईट? इंटू ब्रॅकेट du इंटू ब्रॅकेट 2 into 1 minus u square into bracket minus 2u plus 8 zeta square into u, bracket complete. Okay, is equal to 0. Now simplify further. This term multiplied by 0, 0. This term multiplied by 0, 0. Then what you will get? Only this term is equal to 0. ये यहां आ गए. ये जो टर्म है -1/2 है, मैंने नीचे लिया तो +1/2. That whole term under root this whole term into 0 is equal to 0. So you will get this equation. Okay, only this term is remaining. So you will get equation 2 into 1 minus u square into bracket minus 2u plus 8 zeta square into u is equal to 0. This term is remaining only. So I have written this term is equal to 2 into bracket 1 minus u r Now we are going to find resonant frequency. So this U is nothing but now UR, resonant frequency, that is normalized resonant frequency. Okay, so 1 minus UR square into bracket minus 2 UR plus 8 zeta square into UR is equal to 0. Now this is the equation. Now simplify for, yes, for UR. So this term UR get cancelled. Okay, so I have taken this negative term on this side. Okay, so I will get 2 8 zeta square UR is equal to 4 UR 1 minus UR square, bracket complete. So this 4 get cancelled, 4 4 दूनी 8, so 2 zeta square, okay, is equal to 1 minus UR square. Right? Are you with me? 2 zeta square is remaining on LHS. On RHS, only 1 minus UR square is remaining. Now proceed further. UR square is equal to 1 minus 2 zeta square. UR is equal to under root of 1 minus 2 zeta square. So this equation you have to remember again here. This equation, just draw the square bracket for this equation. So this equation you have to remember. Okay, UR is equal to under root of 1 minus 2 zeta square. That is very important. Now what is U? U is normalized frequency, and that is given by equation omega divided by omega n. That is natural frequency. And omega r is equal to UR is equal to omega r divided by omega n. You can write, okay, for resonant frequency. So omega r is equal to UR into omega n. Omega r is equal to UR into omega n. So you will get the equation for resonant frequency omega r is equal to omega n into bracket 1 minus 2 zeta. So this is also important equation you have to remember. Okay, so this is how you have derived the equation of resonant frequency omega r is equal to omega n into bracket into under root 1 minus 2 zeta square. So if the value of natural frequency omega n is given and damping factor is given, that is zeta, you can calculate the resonant frequency omega r. So student, please write this equation. This is very important equation for resonant frequency in case of second order system. Are you with me, students? Got the derivation? Any doubt?
Yes, ma'am.
So this is what about resonant frequency. You got the equation. Now, according to definition of bandwidth, now we are going to find bandwidth. According to definition of bandwidth, what you have to do? Mod of MJU is equal to this equation is equal to 1 by root 2 and is nearly equal to 0.707. So how to do this? For this, you have to take mu square is equal to, you have to simplify, mu square is equal to 1 minus 2 zeta square plus or minus, this is the characteristics equation I am going to write, okay, u square is equal to 1 minus 2 zeta square plus minus under root of 4 zeta raised to 4 minus 4 zeta square plus 2. So with this equation, you know u is equal to omega divided by omega n. You will get equation for bandwidth. BW is equal to, in terms of omega n and zeta, we are going to take only positive roots, okay, because frequency is having real value only, real quantity. There is no any imaginary part in frequency, right? Axis. So we are going to take only positive value and neglecting negative value. So you will get bandwidth is equal to, bandwidth is nothing but difference between higher frequency and lower frequency. So you can write equation of bandwidth is equal to, in terms of omega n, omega n into bracket, yes, under root of 1 minus 2 zeta square bracket complete plus or minus under root of 4 zeta 4 minus 4 zeta 2 plus 2 bracket complete. So this is the equation for bandwidth you have to remember. So please write this equation, student. This is the equation for bandwidth. Okay, according to the definition of bandwidth. Are you with me? समझलं कसं आलंय ते? Any doubt? चलो मैं समझाती हूँ अभी. Now next we are going to derive the equation for MR, maximum peak, resonant peak. Starting with this point, U is equal to UR, that you know UR is equal to under root of 1 minus 2 zeta square, right? Magnitude of MUR, just put UR, U is equal to UR. So magnitude of UR is equal to, you can write this equation 1 divided by under root 1 minus UR square bracket square plus 4 zeta square UR square under root में. Now resonant peak MR is, resonant peak is denoted by this letter MR. Maximum resonant value is nothing but resonant peak. So this resonant peak specification is denoted by letter capital M suffix R is equal to 1 divided by, what is UR? UR is equal to under root of 1 minus 2 zeta square. So put this equation over here instead of UR and simplify. You will get equation for resonant peak. So similarly, MR is equal to resonant peak, MR is equal to 1 divided by under root of bracket में 1 minus, what is UR? UR is 1 minus 2 zeta square. UR चा square है, square and under root get cancel, bracket complete, bracket square plus 2 zeta square. What is UR? UR is equal to this term under root UR square is equal to 1 minus 2 zeta square. So put UR square is equal to 1 minus 2 zeta square. Simplify for that. MR resonant peak is equal to 1 divided by under root. Simplify karo isko. You will get this equation 4 zeta raised to 4 plus 4 zeta raised to 2 minus 8 zeta raised to 4. Now simplify, you will get resonant peak MR is equal to 1 divided by under root of 4 zeta square minus 4 zeta raised to 4. So MR, that is resonant peak, is equal to 1 divided by 2 zeta into under root of 1 minus zeta square. Okay, 1 minus zeta square. So this is the equation for resonant peak MR. At resonant frequency, you will get resonant peak. So you are having now equation for resonant frequency, you are having equation for resonant peak. Okay, now from this equation, you are going to draw the frequency response. So please concentrate on equation of resonant frequency, omega R. Please concentrate on equation for resonant peak, that is MR. So student, you are supposed to write all these equation, final equation in summary. Okay, for resonant frequency, this is the equation. For MR resonant peak, this is the equation. You are going to remember it because that is needed while solving the example related to second order system, right? Are you with me? Any doubt up to this? Any doubt? Write all these steps in your notebook. Now चलो अभी plot करते हैं. So at U is equal to 0, magnitude of U is equal to 1. Okay. At U is equal to infinity, magnitude of U is equal to 0. So with this equation, just plotting the frequency response, see, at U is equal to 0, on x-axis I have taken U. Okay, what is U? U is normalized frequency. And what is M of U is nothing but magnitude. of mu. So magnitude of mu I have taken on y-axis. Now magnitude of mu is equal to 0, is equal to 1 when u is equal to 0. So u is equal to 0, magnitude is equal to 1. This is the point. Now when at u is equal to infinity, magnitude is equal to 0. Okay. But at normalized resonant frequency, you are having maximum peak, resonant peak, that is nothing but mr. So this mr is nothing but resonant peak at resonant frequency. Okay, you are. Got my point? And if this u is increased up to infinity, thus magnitude is decreasing to 0. So this is the response, that is magnitude response I have plotted. Okay, with normalized frequency u. Now next, coming to next block, just moving in upward direction. Just wait. Now it is clear. So this is nothing but again at u is equal to 0, m0, magnitude of mu is equal to 1, and at u is equal to infinity, magnitude m infinity is equal to, yes, is equal to 0, right? Now drawing the bandwidth. How to draw bandwidth? Hey baba, हे तर काढलं u is equal to 0 or omega is equal to 0. You can say maximum magnitude of your system is equal to 1. So I got this point. Okay, and at resonant frequency I got resonant peak mr. Okay, this is the resonant frequency. But this is the resonant frequency. Okay, this is u. Now this is nothing but your resonant frequency, and this is nothing but resonant peak denoted by letter mr. So when u is equal to 0, magnitude of mu is equal to 1. So you got this magnitude. Okay, now talking about frequency, sorry, talking about bandwidth. So bandwidth is nothing but you will get equation for bandwidth. I have shown, I have given the equation. So you, if you simplify, you will get bandwidth is equal to 1 divided by √2 into magnitude mu. Okay, that 1 divided by √2 is nearly equal to 0.707, right? So this is nothing but, so you can draw a line from 0.07 when this line is touching to this plot. Take the vertical projection, and this much is nothing but your bandwidth. From this point to this point is nothing but your bandwidth of your system. Got my point? Any doubt up to this? Any doubt, students? So draw the response with u is equal to 0 and with u is equal to infinity. The small part is remaining, just moving forward. How you will get the equation for bandwidth? So bandwidth is equal to, for that, starting from this point, magnitude of m of u is equal to, what is equation for magnitude? 1 divided by under root of 1 minus u square bracket square plus 4 zeta square into u square, that you know very well, right? At u is equal to ub. So what is this ub? Just I am going to put u is equal to ub. That is nothing but natural frequency, normalized frequency for bandwidth, for finding the bandwidth. So I have taken u is equal to ub. जे तुमच्या लक्षात आलं की this is the derivation in order to get equation for bandwidth. So I have taken u is equal to ub. Okay, so magnitude of ub is equal to 1 divided by root 2 into magnitude m of 0, right? So what is this m of 0? 1 divided by under root of, same equation, just write instead of ub. So 1 minus ub square bracket complete square plus 4 zeta square into ub square is equal to 1 divided by root 2 as it is. This m of 0 is equal to 1. आता बघितलं ना आपण, is equal to 1. u is equal to 0 असेल तर काय होतंय? When u is equal to 0, magnitude of u0, u is equal to 0 is equal to 1. So I have written over here 1 instead of this, is equal to 1. Now simplify. You will get this equation. Cross multiplication and taking square of this, you will get 1 minus ub square bracket complete square of that bracket plus 4 zeta square ub square is equal to 2. Now simplify. This 2 is coming on this side. Simplification 1 plus ये bracket simplify करते हैं पहले. 1 plus ub raised to 4 square 4 minus 2 ub square plus 4 zeta square ub square is equal to 2. Now this 2 coming on this LHS side with minus sign, so you will get minus 1. So you will get equation ub square minus 2. What is ub? ub is nothing but 1 minus 2 zeta square. Okay, ub square common घेतलं आपण. Okay, so minus 2 into 1 minus 2 zeta square into ub square. Minus 1 is equal to 0. Now this is nothing but your equation, quadratic equation झालं ना. So just put ub square is equal to x. Then you will get simplified equation. So ub square is equal to x put केलं आपण. So you'll get equation x square minus 2 into bracket 1 minus 2 zeta square bracket complete into x minus 1 is equal to 0. Now this is simplified equation, quadratic equation. So you can solve this equation, find out roots of this equation. How to find root? Yes. 2b plus or minus under root of b square minus 4ac. बरोबर? Divided by 2a. Now x is equal to 2 into 1 minus 2 zeta square bracket complete plus or minus under root of 4 into b square. So what is b? b is this plus 4ac. A is equal to 1, c is equal to 1. So plus 4 divided by 2a. Okay. So from this equation, you will get roots. But as this ub is nothing but frequency, so frequency is again having real quantity. So if you consider this minus sign, you will get imaginary term. So ignore that minus sign, concentrate on plus sign. So we are going to take plus only. So x is equal to ub square is equal to 1 minus 2 zeta square plus under root of this term, under root of 1 minus 2 zeta square bracket complete square plus 1. Okay. Now ub is equal to under root of this term. So ub is equal to square आहे इथे. ub square is equal to this term. ub is equal to under root of same term 1 minus 2 zeta square bracket complete plus under root of 1 minus 2 zeta square raised to 2 plus 1. Now this is nothing but हे काय आहे? What is this? This is nothing but omega b divided by omega n. ub divided by omega n. ub is nothing but omega b divided by omega n. So what is bandwidth? Bandwidth omega b is equal to omega n into ub. So omega n into bracket into under root of the same term as it is. So you will get equation for bandwidth omega b. Equation for bandwidth is equal to omega n is natural frequency into under root of bracket में minus 2 zeta square plus under root of this term 1 minus 2 zeta square raised to square plus 1. Got my point? So student, this is the equation for bandwidth. Got it? Any doubt up to this? So student, you are supposed to write all these steps in your notebook, and please go through it again, go through it twice, then you will come to know how you are having equation for resonant frequency. You have derived the equation for resonant frequency, you have derived the equation for resonant peak, then we have find the equation for bandwidth. Okay, and we have plotted it by taking u is equal to 0, by taking u is equal to infinity, you have plotted the response. Okay, frequency response. So understood, students? Any doubt up to this? Yes, students, any doubt?
No, ma'am.
Okay,
No, ma'am.
thank you, Vita. Thank you. So I have taken your lunch break, 15 minutes. So please write your roll number in chat box with understanding, then you are free to move. Thank you all. I'm also having a lecture at 1:15 p.m. So we'll stop here. Thank you for patient listening.